All right, we're going to start our new unit today. In particular, we're going to be moving along with trigonometry. We've done trigonometry, right triangle trigonometry. We've done some triidentities and proofs. We've worked with law of sines, law of cosines, finding the triangle area using some variants of law of sines. So now we're going to move on to angle measures and that elusive thing on your calculator that when you were working with right triangle trigonometry, I told you, make sure you're in degree mode because all our angle measures are given in degrees right now. And we'll talk about what radians, that other mode, is, and how we can use that to measure angles. Okay, so let's talk about angle measures and try to extend our definition of what an angle measure is. So rather than thinking of an angle as just a set of two lines that meet at a certain point and the degree measure in between them is what we call the angle measure, instead of thinking of it like that, we're going to think of it as a ray. So we're going to think of it as a ray that rotates around the endpoint. So the endpoint stays in the same place. So if you remember a ray from geometry, that's an object that has an endpoint on one side and has an arrow on the other side. So if that endpoint stays, and then the rest of the ray rotates around that endpoint, we're going to think of angle measures this way. So the vertex is the endpoint, okay? And then the starting position of the ray is what we're going to call the initial side. And the final position, so after you rotate a certain amount, that is going to be what we call the terminal side. And here are some pictures, just so you can see. I know it's a little bit harder to see, but in blue there, we have this little arrow that shows us that we're rotating starting from the initial side, and we rotated upwards to the terminal side, okay? And we would say that's a 40-degree angle. Now, what's neat about this extension of this definition is that this actually allows us to talk about what we call negative angle measures. So in geometry, we don't see negative angle measures because we don't use this definition when we're talking about angle measures. But when we have a negative angle measure, it's really just a way of expressing the direction in which we're rotating. So here is an example. So we're rotating, notice here, we're rotating in the clockwise direction. So when we rotate in the clockwise direction, that means that we are rotating a negative angle measure. Okay, a couple more things as we're talking about before we get into what radians are, but as we continue with this definition. As we continue to work through this chapter, through this unit, we're going to be using what we call standard position. So standard position is when the vertex is at the origin and the initial side is on the positive x-axis. Okay, so standard position is when the vertex is at the origin and its initial side is on the positive x-axis. Okay, so two pictures here. So we already briefly mentioned when you have a positive angle measure, when you have a negative angle measure, but notice for both of these, the initial side, the starting side before rotation, is on the positive x-axis. Okay, so that's what we call standard position. We start with that initial side on the positive x-axis. The vertex is at the origin, and we rotate around either clockwise or counterclockwise. Okay, another term that will be important for you to know is coterminal angles. So coterminal angles are angles that are formed by different rotations that have the same initial and terminal sides. So if you think about these pictures that we have here, there are multiple ways you can rotate to get to the same endpoint, right? So for both of these, we start in standard position, so we're starting on the positive x-axis. For that first one, for example, we rotate up. Let's say that's 50 degrees. We could also rotate clockwise 310 degrees, and we would end up in the same place, but we would call that negative 310 degrees, which would be the same as positive 50 degrees. So those would be what we call coterminal angles, angles that are formed by different rotations, so they have a different name, but they have the same initial and terminal sides. Okay, so we're going to take a look at an example. So find three angles coterminal with an angle of 60 degrees in standard position. Okay, so one way you can think about this, and I think is probably the easiest way to think about it, is if you rotate 360 degrees, you end up in the same place where you started. So when you're finding an angle that's coterminal, you can either add 360 degrees, so you're rotating counterclockwise to get an additional 360 degrees, or you can subtract 360 degrees. That means you are rotating clockwise 360 degrees, and you'll end up in the same place as well. So for example, you can say 60 degrees plus 360 degrees is 420 degrees. So you'll see in green there, if we rotate 60 degrees, we end up at that terminal side. If we rotate 60 degrees and another 360 degrees, which is that blue swirl there, then we rotated 420 degrees. So we would say 60 degrees and 420 degrees are coterminal angles, right? You have the same initial and terminal sides, but a different way of rotating to get there. So we can do the same thing. We can, instead of adding 360 degrees, we can also subtract 360 degrees. So let's do that as well. So 60 minus 360, that gives us negative 300. Okay, so you can see from the picture here, so again, the 60 degrees is that original one that was given to you, that's in green there. If you rotate clockwise, then you end up, so first, because it's rotating clockwise, it's going to be a negative angle measure. And then you can also think about it as, well, how much do I have to rotate to get to the same place? That would be 300 degrees. For those of you who aren't as much into the visual, you should understand it, but you also should know you can just take the 60 degrees and subtract 360 degrees from it. Now, there are actually an infinite number of ways that you can come up with coterminal angles. This example asks you to find 3 of them. So it's not just that you can add 360 or subtract 360, but you can continually add 360 or subtract 360. So, for example, if instead of adding 360 degrees, we added 2 360 degrees, so we rotate an extra 2 times around, we can also get another coterminal angle. So, for example, 60 plus 2 times 360 is 780. So, again, looking at the blue swirl there, we start at the positive x-axis, rotate 60 degrees, and then we rotate 360 degrees and another 360 degrees. And we'll end up in the same place as the 60-degree angle. So 420 degrees, negative 300 degrees, and 780 degrees are all coterminal angles with an angle of 60 degrees. All right, let's keep going. Okay, so let's talk about arc length. So this requires us to review a couple of geometry concepts. So when we're talking about arcs, we're talking about a circle. So an arc is part of a circle. So if you remember, so a circle, you all know what a circle is, but an arc is just one piece of that circle, right? One part of a circle. Now, a central angle is an angle whose vertex is the center of the circle. Okay, central angle is an angle whose vertex is the center of the circle. Now, the arc length, so the length of the arc, is going to depend on the radius of the circle and the measure of the central angle. So, if you were trying to find just one piece of the circle, and how long that is, just as if you were taking a tape measure to measure that, but you don't have a tape measure. But if you know the radius of the circle, you can find out what the circumference of the circle is, right? 2 pi r. And if you know the measure of the central angle, then you know what part of the circle it is. So for example, if you have an angle of 180 degrees, you know that's half of the circle. So you know that that arc length is going to be half of the circumference. Okay, so let's just write down a proportion that shows us this. So normally with arc length, we use a cursive L, and we would say the arc length is part of the whole being the circumference of the circle, so that's 2 pi r, so L over 2 pi r, equals, and then on the other side of the proportion, again, we're doing part to whole. So on top, we put the measure of the central angle, so we call that theta, and put that over the whole. So for a whole circle, you know that's 360 degrees. Now, if you wanted to find the arc length, get arc length by itself so that you can find the arc length of any arc that's given to you, of any circle with a certain radius, of which you know the specific angle measure. Well, all you need to do is do a little bit of rearranging, and we're just going to go ahead and multiply both sides by 2 pi r. And we'll try to simplify this as much as we can. So the 2 and the 360, we can simplify that down. So this will be theta pi r over 180. So we can write this down. So the arc length is equal to theta times pi times r all over 180. Okay, so let's use this, and this is going to eventually lead us into talking about what radians are, but we're not quite there yet. Let's take a look at example 2. So we're going to find an angle given an arc length. So an arc in a circle has an arc length L, which is equal to the radius r. Find the measure of the central angle that the arc intercepts. Okay, so this one's kind of working a little bit backwards. You are trying to figure out the measure of the central angle, so that's finding out what theta is. Now you aren't told exactly the measurement of the arc length or the measurement of the radius, but you do know that they are equal to each other. So let's write that down. So the radius is equal to the arc length. Okay, now what did we just say that the arc length is equal to? We just said the arc length equals theta pi r over 180. All right, we just wrote that down before this. Okay, let's get rid of that denominator, so I'll multiply both sides by 180. Now look, we have an r on both sides, so I'm going to go ahead and cancel that from both sides, which leaves us with 180 equals theta times pi, and remember, we're trying to solve for theta. Pi is a number, right? So we'll divide both sides by pi, so we have 180 over pi. So the central angle measure, if the arc length that you're looking at is equal to the radius, is equal to 180 over pi, which is about 57.3 degrees. Okay, now how does this relate to radians? So this particular example, where the arc length is actually equal to the measure of the radius, is actually exactly how we use radians. So when we're talking about radians, first of all, we're talking about a unit of measuring angles, right? So for example, if you were measuring a length, you could use centimeters, you could use inches, right? It's a different unit of measurement. So we're going to talk about, well, where does the radian measure come from? And then how do we convert back and forth between angles and radians? So radian measure is a unit of angular measure where an angle that is 1 radian cuts a circle such that the intercepted arc is exactly the measure of the radius of the circle. So in other words, if you take the radius of the circle, you take whatever that length is, and you line it up along the circumference, right? Whatever that angle that makes is going to be what we call 1 radian. Okay, now we just actually found this in the last example, because in the last example, you'll notice that we said the radius and the arc length are the same. So we actually know that 1 radian is equal to 180 over pi degrees. Okay, so we'll write that down. 1 radian is equal to 180 over pi degrees. Now we already talked about this with degree measure, but we'll emphasize it here again because we're talking about radian measures. So if you rotate counterclockwise, that's going to be a positive radian measure. If you rotate clockwise, that will be a negative radian measure. Okay, now these 4 examples that we have down here is just to show you what 1 full rotation or 1 revolution around, how many radians that is. Okay, now notice in this we have a circle that has a radius of length 1. Okay, so if you were thinking about, well, what's the circumference of that circle? That's 2 pi times 1, so that's 2 pi. Okay, so we would say that 1 full rotation around is going to be 2 pi radians. Okay, if you rotate 3/4 of the way around, that's 3/4 of 2 pi, so 3/4 times 2 pi, which is 3 pi over 2 radians. Right, if you rotate only halfway, that's 1/2 times 2 pi, which is pi radians. If you rotate 1/4 of the way, that's 1/4 times 2 pi, which is pi over 2 radians. Okay, so you kind of have sort of an idea of approximately how many radians something would be as you rotate around the circle. Generally, we will be using radians in terms of pi, just because that actually makes it a lot easier for us to be able to work with, because we are relating, when we're talking about radians, we are relating it to the radius of the circle, we are relating it to the circumference of the circle. Okay, so just a little visualization for those of you who might still be having a hard time imagining what a radian measure is. Okay, so here we have a circle being drawn. It has this red line, that's the radius r. If you take that radius and we put it along the circle, right along the curve there, and that angle measure is 1 radian. Now we can measure 1 radian, we can measure what 2 radians are, we can go up to 3 radians, and then there's a little bit left. That takes us to pi radians. All right, and then if you were to rotate all the way around from here all the way to the back to where you started, that would be 2 pi radians. Okay, so that hopefully gives you a little bit of a better idea of understanding what radians are. Okay, now this big spider web thing that you see here is what we call the unit circle. And there are certain angle measures that you'll see relate to the special right triangles that I made you guys memorize those angle measures, and the sine, cosine, tangent of those angle measures. We're going to be using them here. For now, we're just going to go around the circle and we're going to list off all these important angle measures. And we will write them in both degrees and radians for now, just so that we kind of get used to seeing degrees as it relates to radians, but we are eventually going to move to just working in radians. Okay, so starting here, right on the positive x-axis in standard form, this is going to be 0 degrees or 360 degrees, right? So either we haven't rotated at all or we've already rotated all the way around. All right, so it can either be 0 degrees or 360 degrees. It could be 0 radians or 2 pi radians. All right, next, on the opposite side, we have 180 degrees, which is equal to pi radians. All right, halfway between those two, 90 degrees, that would be pi over 2 radians. Okay, and then 3/4 of the way, that is 180 plus the 90, so 270 degrees, which is going to be 3 pi over 2 radians. Okay, so now we're going to go through and do those special angles that you guys have memorized, 30 degrees, 45 degrees, 60 degrees. So here we go, right halfway in between, that's the 45-degree angle. So in radians, that would be pi over 4. Right, half of pi over 2 is pi over 4. Okay, we'll do all the ones that relate to 45 degrees. So after the 90-degree angle, if we add another 45 degrees, we're at 135 degrees, and that is 3 pi over 4. Okay, we go 45 degrees past 180 degrees, that is 225 degrees, and that's 5 pi over 4. Might be noticing a pattern here. We have everything over 4 right now. And then continuing on, 45 degrees past 270 degrees, that is going to be 315 degrees, which is 7 pi over 4. Okay, so you can notice all the ones that related to the 45-degree angle, all in radians, was over 4. All right, let's keep going. So now we look at the 30-degree angle here. That's pi over 6. Right? You can think of that as a third of 90 degrees. So a third of pi over 2 is pi over 6. All right. If we go another 30 degrees, that's going to be at the 60-degree angle. So that's pi over 3. You can think of this as 230 degrees, right? So pi over 6 plus pi over 6 is 2 pi over 6, which is pi over 3. Okay, and then we're going to continue this and continue through and do 30 degrees past 90, 60 degrees past 90, and so on. So 30 degrees past 90, that's 120 degrees, that's 2 pi over 3. Another 30 degrees takes us to 150 degrees, which is 5 pi over 6. 30 degrees past 180 degrees is 210 degrees, which is 7 pi over 6. Another 30 degrees past that is 240 degrees, which is 4 pi over 3. Go 30 degrees past 270 degrees, that's 300 degrees. That's 5 pi over 3. Another 30 degrees takes us to 330 degrees, which is 11 pi over 6. All right, I know there's a lot going on there at this point. We will come back to using this quite a bit. You will see the unit circle as you go to calculus. So it is important that we kind of introduce it now. You can see how the degree measures relate to the radian measures. I know there are a lot of numbers in here, but the point is, I know with the fractions it looks confusing right now because they are fractions. You're not used to seeing pi in there, but the more that you end up looking at it, the more you'll end up actually seeing a lot of patterns when you're looking at the radian measures, and not as many patterns as when you look at the degree measures. So, for example, if you look at all those fractions, they're all either over 2, over 3, over 4, over 6, right? So, and then if you take a look and see where are the fractions that are over 6, you'll notice that there actually is some symmetry to it, where all the ones that are over 4, or over 3, or over 2, there is a symmetry that is in this unit circle that we'll be taking a closer look at later on. Okay, let's talk about how to easily convert back and forth between degrees and radians. Now, before we had said that 1 radian is equal to 180 over pi degrees, so that's actually what we're going to use here. So if you're converting something from radians to degrees, you want to multiply by 180 over pi. Now, if you're converting the other way around, from degrees to radians, you're going to multiply by pi over 180. Okay, so just the reciprocal you're going to multiply by. All right, let's take a look at example 3. We're going to convert from radians to degrees. So pi over 5. Remember, from radians to degrees, you want to multiply by 180 over pi. Okay, so if you multiply by 180 over pi, notice the pi in the numerator and the pi in the denominator cancel. That leaves us with 180 over 5, which is equal to 36 degrees. Okay, and we can do the same thing for the others. So 4 pi over 9, multiply that by 180 over pi. Again, pi cancels, you're left with 4 times 180 over 9, which ends up being equal to 80 degrees. Do the same thing with 6 pi. So we multiply 6 pi by 180 over pi. Pi's cancel, you're left with 6 times 180, which is 1080 degrees. All right, great. Last example, we're going to convert the other way around. We'll convert from degrees into radians. So we have 75 degrees. Now, one important thing to note here, we are going to keep our radian measures in terms of pi. So I know you're quick to maybe bring out the calculator, which is fine, but don't plug in times pi into the calculator. Leave it in terms of pi. So for example, 75, we're going to multiply by pi over 180, because we're going from degrees to radians. And all you want to do is simplify the 75 over 180 as a fraction in simplest terms. So that would be 5 over 12, and then put the pi in the numerator. So 5 pi over 12. All right, we'll do the same thing with 220 degrees. So 220 times pi over 180, that's equal to 11 pi over 9. And in the last one, we have 400 degrees. Multiply that by pi over 180, and that is equal to 20 pi over 9. Okay, we're going to talk more about radian measures in our next lesson. But for now, that's all we have.